How to compact VirtualBox's V file size? I've a VirtualBox VM which configured a very large hard disk size, bigger than host. By my mistake, a program on the VM generated lots of log files and the V file size keeps growing until there is no space on the host. Now I've deleted the log files, but the V file size are not getting smaller after using VirtualBox modified c:\verts\mybox i386.v compact. Is there a way to really compact the V file size? Thanks.
You have to do the following steps. Run defrag in the guest, Windows only. Nullify free space. With a Linux guest run this. Or with a Windows guest, downloads delete from sysinternals and run this. Replace C with the drive letter of the D. Shut down the guest VM. Now run VoxManage's modify medium command with the compact option. With a Linux host run this. With a Windows host run this. With a Mac host run this. VoxManage is located here. This reduces the V size.
Debian guest on Windows host using discard/trim. This isn't a direct answer per se, as I'm addressing the problem, not the question. Instead of periodically compacting the image, this solution uses discard to automatically remove unused blocks in the host's VM disk image. This solution requires a guest file system that supports continuous trim. The Arch Linux wiki has a list of file systems supporting trim operations. FDA and CryptoRoot are specifically not covered, as there are security concerns and none of the other solutions to this question would allow compacting either. The Arch Linux wiki has information about trim and DM crypt devices. In theory, this will work for all Linux guests on VBox hosts using dstorage. Host configuration. With VBox exited and no VMS running, add discard support to your disks by setting both discard and non-rotational for each disk in the config file for the VM. At this time discard is not in the GUI, but non-rotational is exposed as the solid-state drive checkbox. Ref, VBox forums, discard support. Boot the VM up, and verify that trim support is enabled. Guest configuration. If LVM is in use, change the discard setting in /etc/lvm/lvm.conference, ref, Debian wiki, lvm.conference example. In stab, add the discard option to the file systems you wish to auto-discard, ref, Debian wiki, stab example. Remount the file systems to have them pick up their new options. Manually trim free blocks now with vstrim. Vstrim uses the mounted file system, not the block device backing it. Instead of setting continuous discard in stab, this could be done on a weekly cron. The weekly cron is recommended for physical SSDs which may have questionable support for trim, but this is not relevant here since underlying SSDs are handled by the host OS. See, SSD trim warning. At this point, the size of the file systems inside the VM and the size of the VM images should be pretty close in value.
I'm on a Windows 7 host with Windows guests. Here is a batch file I wrote to compact all of the VDIs in a folder tree. I left the links in the comments so you can, sort of, tell how it works. Edit. Well, after all that, I tried the Clone D tool and it did a good job in much less time and in one click.
Important note for legacy, ~1997 to 2007, operating systems. In general, the techniques and the answers previously given are valid. However, there is a very important special case. For a period of some years, perhaps 1997 to 2007 or so, 32-bit operating systems were still the norm, but hard disks larger than 2 GB were already in use. As a result, when attempting to consume all free space by writing a file of zeros, which should always be done as root, to include root's privileged free space, which no one else can touch, you may see file too large, instead of what you expect. No space left on device. If this occurs, you have most likely hit a 2 GB file size limitation. This was common at the time because many file operations returned results in signed 32-bit integers, so that negative values could report error codes. This effectively meant that offset results were limited to 2 to the power of 31 bytes without special measures. The workaround is straightforward. Keep creating separate, differently named zeroing files until the disk actually runs out of space. If you are an instructor wishing to demonstrate this situation for a class, a 4 GB disk image with an old copy of Red Hat Linux 7.0 is sufficient.
Yeah.